Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video is for the chapter 3, comparing two population independent samples for the course of SMS 3123. So basically for this video, you will learn about the independent sample for non-parametric tests, which include Mann, Whitney test. So I will begin with some introduction and then followed by the analysis for small samples with example, and then followed by the large sample, just the method only for the large sample. Okay, so while comparing to independent small samples and the outcome is not normally distributed, so a non-parametric test is appropriate. So remember the characteristic of the data in which situation that you may use non-parametric test is whenever the data is not normally distributed. So one of the common non-parametric tests that can be used to compare between two independent groups is Mann-Whitney test. So sometimes this Mann-Whitney test, if you search or Google, you may find they sometimes call it as a Wilcoxon rank sum test. Okay, but the step is basically similar. However, for this video, I'm focusing on Mann-Whitney test. Okay, but when you find further information about this, you might found about Wilcoxon rank sum test. Okay. Okay, so if you do further reading, you might find that some investigators or researchers, they interpret this test as comparing the medians between the two populations, because it is non-parametric. So most of the time we're dealing with the median of the population. Okay, so this is if you can remember in SMS 3033, so you learn about parametric tests. So in that test, we compare means between independent groups. Okay, so in this non-parametric, we use Mann-Whitney test to compare median between independent groups. So the hypothesis that you can write for the non-parametric test, especially for this comparison between two independent groups, is we are looking at the populations. So you might write down as two populations are equal, and the hypothesis alternative is the two populations are not equal. Sometimes you may write the hypothesis null as identical distribution, and hypothesis alternative as non-identical distribution, or shifted to the left or shifted to the right. Okay, this Mann-Whitney test is often performed as a two-tailed test or two-sided test. Okay, so there is a hypothesis indicates that the population are not equal as opposed to specifying directionality. So Mann-Whitney test always begins with two-tailed tests. It depends on the question given. So most of the time it is two-tailed test. That's why if you are given a question about whether the distribution between two populations are the same or not, so it's referring to two-tailed test. That's why the alpha for two-tailed test, you just use the given alpha, but if there's one-tailed test, you need to double the alpha. Okay, that's what it means. So when you dealing with data and you want to analyze using Mann-Whitney test, so please bear in mind that you are referring most of the time to tail test. Okay, so one tail test, if you want to check whether the distribution the distribution, or you want to detect a positive or negative shift in one population as compared to the other. So how to decide whether it's one tail or two tail? Most of the time it's based on the question given. Okay, I will show you the example later on. Okay, so the basic procedure for this test is based on rank. Okay, so you combine two sample and then you give rank from lowest to highest for both N1 and N2. So as a summary, so we will say that this Mann-Whitney U test is basically test two independent population probability distribution. And if we compare to the parametric test, it is actually corresponds to t-test for two independent means. And assumption in which situation that you can use this Mann-Whitney test is basically we assume the samples random and independent and the population are continuous, and we can use normal approximation, or in this case is large sample if it is Ni, which refer to N1 greater than or equal to 20 and N2 greater than or equal to 20. Some book they write down 10 and above as large. Some books write 30 and above. Okay, for here I'm using 20 and above as a large sample. Okay, let's first look at the small sample analysis. So I will divide into two, one tail test and two tail test. So the first step as usual is hypothesis. Hypothesis null, hypothesis alternative. This is another way to write down the hypothesis. For instance, you let D1 and D2 represent the distribution for population 1 and population 2. So you may write down as D1 and D2 are identical. Because this is one tail test, D1 is shifted to the right of D2. Or if this left tail test, it becomes D1 is shifted to the left of D2. This is one tail test. You might also mention here for hypothesis null, for instance, identical distribution. And then next is the test statistic. So Wi here represents sum of rank. U1 is equal to N1 N2 plus N1 times N1 plus 1 divided by 2 minus W1, which is referring to sum of rank for the first group. And then we have another one here, U2 equal to N1 N2 plus N2 times N2 plus 1 divided by 2 minus W2, which is referring to the sum of rank for group 2. Okay, so the test statistic which that will be used is basically the smallest one. After you calculate U1, after you calculate U2, and then you pick the smallest value or the smallest or the minimum value of U1 between U1 and U2. And you use that to test with the U critical value. Okay, so rejection region basically, if this one tail test, so you compare with the critical Mann-Whitney U from table. I will show you later on in the example how to read the table. And when you give rank, so I write down here ties, there is a situation where the data is exactly the same between two groups. Okay, so how to give the rank is basically you take the average of the rank. For instance, the rank is 3 and 4, so you take the average of the rank, 3 plus 4 divided by 2. So the rank is 3.5 for both data. Okay, again, this one I will show you in the example. Okay, so this is the case for two tail test, so nothing much different for the hypothesis. But the different alternative here, you have both hypothesis null, D1 equal to D2 or identical. Hypothesis alternative is either D1 shifted to the left or to the right in one sentence. Or you may write down here non-identical distribution. Okay, look at the test statistic. This is the one that I mentioned just now. What is U1? What is U2? Use the same formula as in the one tail test. So you took the minimum value between U1 and U2 and you use that as your test statistic. Okay, the rejection region, you compare the U test statistic with U critical from table. Okay, so this two is basically the condition required for valid Mann-U test, which is the first one. The two samples are random and independent, and the two probability distribution for which the samples are drawn are continuous. So these two condition must be fulfilled before you can use this Mann-Whitney test. Okay, so the common procedure for Mann-Whitney test. So first thing first, you need to rank the data to the N1 plus N2. N1 plus N2 referring to both data from group 1 and group 2. If unequal sample size, let N1 refer to smallest sample size. If they have unequal sample size, you let N1 for smaller sample size. So we begin with the smaller sample size first. Smallest value, when we give rank, start with 1. Average size here means if the data is the same, so we need to take the average. And then after you give the rank, you need to sum the rank, and then you write down W1 for group 1 and W2 for group 2. And next step is you find the test statistics UI, which using the formula that I showed you just now, you find UI and then you find U1 and U2, and then take the smallest one before you compare with the U critical from Mann-Whitney U table. Okay, let's look at the example. So this is the first example 1. Suppose that you are a production planner. You want to see if the operating rates for two factories is the same. For instance, for factory 1, the rates are 85, 82, 94, and 97. So N1 is equal to 1, 2, 3, 4. N1 equal to 4. And for factory 2, the rates are 71, 82, 77, 92, and 98. So N2 is equal to 1, 2, 3, 4, 5. So the question is, do the factory rates have the same probability distribution at the 10% level of significance? So this is obviously because you want to check this whether it's the same or not. So this is a two-tailed test. Okay, two-tailed test, your alpha is 10% or 0.1. So that's the information that you need to pick up, which is N1 equal to 4, N2 equal to 5, and your alpha is 0.1. So let's look how to solve this question. Okay, first thing first, you identify it as a two-tailed test. So your hypothesis alternative is either you write down shift of left or right, or you may also write down non-identical distribution, or you may also can write down in terms of D1 or D2. Okay, as long as the hypothesis can be understood, then it should be fine. Okay, and then this is all this both step 1 and step 2 is basically based on the data given. You are given alpha 0.1, N1 equal to 4, N2 equal to 5. So you may find critical value from table just by looking of this information, and I will show you how to find the critical value later. Okay, let's first step is you need to rank the data. So here is the data for factory 1, 85, 82, 94, 97. So we have N equal to 4. This is the data for factory 2, which is the rate 71, 82%, 77, 92, and 88. So we have N equal to 5 here. Okay, so look at the smallest value. So obviously 71 is the smallest value. So you give the rank 1. What is the next lowest? 77. So you give rank 2. Next, we have 82 here for both in factory 1 and factory 2. So the rate here is ties. Okay, so the same value. So we need to take the average. It's either you put here 3, 4, or you put here 3 and here 4. It's okay, no problem. Okay, so because it has the same data, so the rank is not 3 and not 4. Instead, you need to plus and divide by 2. So this is what happened. Okay, rank 3 and rank 4, 4 plus 3, 7 divided by 2, 3.5. That's why the rank for number or data 82 is 3.5. So next is 85 with rank 5, 88 rank 6, 92 rank 7, 94 rank 8, and 97 rank 5. So that's the process of ranking. So done for your ranking. Remember the procedure, the second step is you need to sum the rank. You total up the rank for each factory. So here W1 is the total rank for factory 1 and W2 here is the rank for factory 2. You just sum up this figure 5, 3.58 and 9 you got 25.5. And for the factory 2, 1 plus 3.5 plus 2 plus 7 plus 6, you got 19.5. So that's the second step. So we done the first step and the second step. So what's next? So this is the solution, overall solution for the equation. So this one, we done it before, hypothesis. And we got this information. From this information, we can find the critical value from Mann, Whitney, U test table. Which here we got 2. U critical is 2. How we got 2? I will explain in the next slide. So before that, look at the step 3 for test statistic. Okay, for this test statistic, use the, you have information about W1, which is 25.5. And we have information on W2, 19.5. So what you need to do is you need to calculate U1 and you need to calculate U2 using the formula. After you substitute the value, you got U1 is 4.5 and you got U2 15.5. So what you need to do here to find the test statistic is basically you take the smallest or the minimum between U1 and U2, and for this case U1 is 4.5. So for the decision, since U1 equal to 4.5 here is greater than U critical 2 here, therefore do not reject H null at alpha 0.10 or 10%. Okay, sorry. Alright, so we only reject if U test is less than U critical, but for this case it's greater than, that's why I do not reject, and the conclusion is there is no evidence distribution are not identical. So that's the conclusion. Okay, so let me explain how to get this critical U from table. So I give you the link here, so later you may copy paste this link and find all the tables. So remember I said in the introduction, for Mann Whitney U test, most of the time it's referring to two tail. That's why here is the two tail. Okay, so from the question we know that alpha is 0.1. So this is important. First thing first, you need to use a table with alpha 0.1 because in this link we have several type of alpha, some of it 0.05, 0.5, 0.05, 0.0005, something like that. So make sure you choose the right alpha. And then what you need to do is choose your N1. For this case, your N1 is 4. And then look at your N2. For this case, or for the question 1, example 1 is 5. So you have alpha 0.1, N1 equal to 4, N2 equal to 5. So here is the critical U. So U critical, as I show you just now, here is equal to 2. So this is the value that you need to compare with the minimum between U1 and U2, 4.5 here. Okay, that is how you read the table. Make sure you have your alpha, you know your N1, you know N2, and then you got the U critical. So that is the solution for example 1. So let's look at another example 2. Okay, consider that you want to investigate the effectiveness of a new drug. Okay, you have a total of N10 in which the data between placebo and new drug, N1 5, N2 5. So the question is there a difference? Okay, is there a difference? So later on you need to read the question again. Okay, is there a difference in the number of episodes of shortness of breath over 1 week in participants receiving the new drug as compared to those receiving the placebo? Okay, Alright, so based on this data, we know it is a two-tailed test with alpha. Did they mention alpha here? Assume it's 5%, N1 5, N2 5. Okay, let's look how to solve it. Okay, so in this example, the outcome is a count data, and the data do not follow a normal distribution. And as I said just now, N1 is equal to N2 5, and we test it using 5% level of significance. In terms of hypothesis, you might write down like this: the two populations are equal, versus the two populations are not equal. You might also write down identical distribution, not identical distribution for alternative hypothesis, alternative. Okay. Okay, here note that if the null hypothesis is true, that means the two populations are equal. Okay, we expect to see similar numbers of episodes of shortness of breath in each of the two treatment groups. And we will expect to see some participants reporting few episodes and some reporting more episodes in each group. Okay, this does not appear to be the case with the observed data. So let's look at the data just now. See the distribution here. This is 7, 4, 5, 6, and suddenly 12. And this is 3, 6, 4 to 1. Okay, so that's why we need to carry out the test to check whether it is there is a statistically significant difference in population. Okay, as usual, the first step is to assign rank. And to do so, we order the data from smallest to largest. Okay, so remember, we total up the data. N1 5 and 2 5 is become 10. So we need to kind of give the rank to the data. The smallest one is 1, so rank number 1. And then 2, rank number 2. And next smallest is 3, rank number 3. Next smallest is 4. But we have both here. In placebo, we have data 4 and data 4. As usual, if the data is the same, we rank it 4, 5, or you may start here 4, 5, and then you need to take the average. 5 plus 4 divided by 2, 4.5, because the data is the same, which is 4. And then next, number 5 is rank 7. And then we have here 6. We have two data 6, so we give number rank 7 and 8, but still the data is the same. That's why we need to take the average. 7 plus 8, 15. So divide by 2, 7.5. And then next, we rank 9 and 10. So that's the rank. The first step is you need to rank the data. So done with the rank. Next, you need to sum the rank, which is W1 and W2. Okay, you sum the rank. 9 plus 4.5 plus 6 plus 7.5 plus 10, you got 37. And then for the new drug, you sum the rank. 3 plus 7.5 plus 4.5 plus 2 plus 1, you got 18. So that's the first step and the second step in calculating the rank and also the sum of rank. So next, if you observe the data and the rank, you can see that the lower rank are assigned to respond in the new drug, while the higher rank are assigned to respond in the placebo group. What does this mean here? You see, 1, 2, 3 is the lowest rank, referring to the new drug. 9, 10, the highest rank, refer to placebo. Okay, so the rest here, nothing to explain, so you may read this. So next, how to solve this? So this is the hypothesis. So similar. Hypothesis is either you write the identical distribution or two population are equal, and then versus the hypothesis alternative, not identical distribution, or the two population are not equal, something like that. Okay, so from the question, we have information about alpha 0.05, n1 equal to 5, n2 equal to 5. So from this information, you may find u critical from table. I will show you in the next slide for this one. And then the test statistics, use the same method. You have W1 37, you have W2 from 18 from the previous calculation. and then you need to find U1 and U2 using the formula. Okay, so for this one, U1, after you calculate, you got 3, and then you calculate U2, you got 22. So the minimum between U1 and U2 is 3, and this will be used to compare with the U critical. So the decision is since U1 is equal to 3 is greater than U critical, which is equal to 2. So do not reject at alpha 0.05. When we do not reject hash null, means there is no evident distribution are not identical. Okay, there is no evident distribution are not identical. So that's the solution, because the question just now we want to check whether they are the same or identical or not. So here we can say that there is no evidence or no enough evidence to say that the distribution are not identical. Okay, so let's show you how to find the critical. It's similar from the previous method. Okay, first thing first, you need to identify your alpha. For this case, is 0.05. And then your N1, 5. Your N2, 5. So your critical is 2. Alright, that's why you got 2 here. So you got 2 here. Then you compare with U1, which is the smallest one. Alright. Okay, so that is for small sample and the example. So for large sample, I just show you the method which is similar. However, because it's large sample greater than 20 for both group, so we may approximate it using normal. So here Z here represent Z distribution, which is normal. So this is the test statistic and the rejection region, which is similar using normal distribution table. Okay, but for this video, I'm only focusing for the small sample, because the large samples we approximate using normal. Okay, so I think that's it for the example and the content about Mann Whitney U test for independent sample. So here, additional exercise 3, you may try to do this. If you have any question, you may ask in our WhatsApp group for immediate response. Okay, and also as usual for attendance purposes, this is task 3. As usual, after you watch this video, you comment done at the comment platform in the YouTube, and then you need to submit the answer for this task 3 question in my group. You make sure you submit within a week so that I can count you as attend. Please let me know any problem related to this course in our WhatsApp group. If you have any question about the topic, the content, the question, or the solution for each task of exercise, please ask in WhatsApp group for immediate response. Okay, so I think that is all. All the best. Assalamualaikum warahmatullahi wabarakatuh.